Here we are on video 3. We left off last time. Going to start question 18 where we are converting 123 degrees into radians. To change degrees into radians, we need to multiply by pi over 180. When I do that, I get 123 pi over 180 radians. Don't forget about the radians part because we're in radians now. And if I simplify by dividing top and bottom by 3, I get 41 pi. That's a pretty ugly 41 pi. 41 pi over 60. Number 19. If we have the point -3, 4 is on the terminal side of an angle in the standard position, find the cosecant. Well, if we are at the point -3, 4, we're right up here. And we are going to find, this side would be -3, this side would be 4. If I use my Pythagorean theorem, I get that my hypotenuse is 5. And I want to find the cosecant. Again, I don't know what the cosecant is, but I can find the sine, and the cosecant is the reciprocal. My sine is going to be the opposite over the hypotenuse, which is 4/5. Reciprocal of that would be 5/4. So I'm going to have 5/4 is my cosecant. For number 20, what is the amplitude of this function sine 4 times, okay? My amplitude is 1/5. That's what that is. This is my b. Remember, to find your period, we have to take 2 pi divided by b. So our period would be pi over 2. And we have a horizontal shift of 1/3 pi to the right. There is no vertical change in this one, so that's all the information. They only asked for the amplitude, which is that number there. Let's move on to question 21. It says, what is the period of this one? Remember, tangent has its normal period being pi, but to find the period, you have to take pi divided by the b, and our b in this case is 6, so our period is going to be pi over 6. For 22, they give us a graph that looks like this, and they ask us what kind of graph would make that. So we're looking for which kind of function would fit this graph. Well, there's two options. Option A, I have a negative sine graph that would look kind of like this, in which case this thing would be a cosecant graph. The other option, which is not near as much fun, is a cosine graph that has a phase shift. So it could be a cosine with a phase shift, in which case it would, kind of look, right? Yeah, not near as cool as the other one, but it's always an option. This cosecant is probably the one that I would have picked first, but it is possible to have a secant with a phase shift. Number 23, we have find the exact value of the expression if it exists. We are finding the arc cosine of 5 pi over 6. If I look at this, it's asking what is the value of the cosine at this angle. If I go over here, 5 pi over 6, I'm over here in the second quadrant. Pi over 6 less than pi, so I have this little angle in here has to be pi over 6, because that would make a straight line with this one. And we know that if it's a 30-degree angle, which is pi over 6, that one would make this one a 60, which makes this one a 90, and so it would be a 1, 2, square root 3, but since we're in the second quadrant, this is a negative square root 3. And we're looking for the exact answer for cosine. Cosine is the adjacent over the hypotenuse, So that would be negative square root of 3 over 2. Next one that we're going to look at is 24. 24 says find the exact value of the expression if it exists, the tangent, inverse tangent of pi over 2. If I look at my angle at pi over 2, that would be right there, a 90-degree angle. We know this point is 0, 1, and we know that the tangent is also the sine over the cosine. So if I plug that in, I get 0 over 1, which is undefined, because you can't divide by 0. Number 25. We have find A. We have a triangle. Let me see if I can draw this triangle. Our triangle says angle C here is 20 degrees. It says angle B is 150 degrees. And it says side B over here is 200 inches. I think if they're looking for angle A, all I would have to do is use the triangle inequality and say 150 plus 20 gives me 170. That would make this a 10-degree angle. Number 26. It says find side C. That's this one over here. I'm going to use the law of sines. It says the sine of 20 over C is the same as the sine of 150 over 200. If I do my cross products, I get 200 sine 20 equals, or divided by the sine of 150. And if I put that in my calculator, I get my C is going to be 136.8. Question 27 says find A, which would be this one over here. I would use the same law of sines. I would say the sine of 10 is to length of 10, as the sine of 150 is to 200. Using my law of sines again, I get 200 sine 10 divided by the sine of 150 equals my side A. If I do a little bit of solving there on my calculator, I get 69.5 inches, of course. Let's take a look at number 28. 28 says we have a triangle with side length A is 19 inches, side length B is 8 inches, and angle C, which is this one up here, is 78 degrees. And we want to find the area of the triangle. We know we have the area of a triangle is 1/2 AB sine C, the triangle question we had on a test once. So I'm going to substitute in, and my sine is 78. Plug that into my calculator, I get the area of my triangle is equal to 74.3 inches squared. For 29, they tell me that the cosine of theta is equal to 3/5 and that the sine of theta is negative. We want to find the cotan of theta. Well, this first one tells me that I have to draw my triangle where the cosine is positive and the sine is negative. So I'm going to say all students take calculus. So it's calculus is positive, cosine is positive in the fourth quadrant. So I'm going to say the adjacent over the hypotenuse. This would be a -4, 3, 4, 5 right triangle. My sine is negative in this quadrant. And I don't know what the cotangent is, but I know it's 1 over the tan. And if I find the tan is the opposite over the adjacent, reciprocal of that would give me -3/4. Number 30 is we're not supposed to do it. Number 32 is where we're at next. They tell us, I'm never going to finish. Let's start another video and finish this.